For this question, we have a graph that shows the distance a car traveled from a starting position along a straight road. And part A is asking for the average velocity of the car between 0 and 20 seconds. And to get that average rate of change, I'm going to use the formula for slope. So it's nice to visualize it first though. For part A, it's asking between here, t equals 0 seconds, and here, t equals 20 seconds, what is the slope of the line between those 2 points? We can use this formula to get it, and it's going to give us the average rate of change. So to start with, for part A, let's see, if we start with t is equal to 0 seconds, that's the point 0, 0. For t is equal to 20 seconds, using the graph, that is the point 20, 300. So after 20 seconds, the car has traveled 300 feet. The slope between these 2 points is going to be, all right, the y values are going to be 300 minus 0, but I'm going to put in their units here. So it's really 300 feet minus 0 feet. And that's all divided by 20 seconds minus 0 seconds. I included the units because if you subtract the numerator, you get 300. If you subtract the values in the denominator, you get 20. And it's going to be feet in the top and 20 seconds in the bottom. If we divide these two numbers, we get 15. But more importantly, not only do we get 15, but we get 15 feet per second. So this is justification as to why the formula for slope will give you an average rate of change, and in this case, velocity, because the units are feet per second. That's a speed or velocity. Same idea for part B. What is the average velocity between 10 and 30 seconds? So that is from this spot to this spot. So it's going to be the line, the slope of the line between those 2 points. So it's going to be a negative number, but that just means the car is going to be traveling backwards towards the starting point. So for B, okay, we have t equals 10 seconds. That corresponds to the point 10, 200. We have t is equal to 30 seconds, and that corresponds to the point 30, 100. And this time, when I figure out the slope, I'll do 100 minus 200 divided by, okay, then it has to be 30 minus 10. I left off the units this time because I know at the very end it's going to be feet over second. So what I'll do is just include the units of feet per second at the end of this process. So let's see. In the top, we get negative 100. In the denominator, we get positive 20. And then 20 goes into 105 times, but it'll be negative 5 feet per second. So this would be the average velocity over the interval from 10 to 30 seconds. It makes sense that the answer is negative because this is a decreasing line between these 2 points. For the last part of this problem, we want to find how fast the car was traveling at 10, 20, and 30 seconds. So this is not an average. This is actually going to be at 1 instant. So for example, at 10 seconds, how fast was the car traveling at this point? Now, we're going to approximate this to get an answer as best as we can, but the way I'll do this is by thinking about what a tangent line to the equation would look like here. So like I'll draw that tangent line and then try to use a couple of points that are on this line. So it's not going to be perfect, but let me draw that on here. I think my tangent line might look something like, I don't know, maybe something like this. This is not perfect, but we're just doing the best we can for this point. So if I was going to use 2 points on this line to figure out the slope, I think an obvious one would be the point 10, 200, and then maybe this point here, which appears to be 2.5, 0. So you may get different points depending on how you sketch your line. I think this will be somewhat accurate. But anyways, for the velocity at exactly 10 seconds, I'm using the points 2.5 comma 0 and 10 comma 200. The slope will give me a velocity. I'm going to do 200 minus 0 over 10 minus 2.5. This is 200 divided by 7.5. I'm going to get this value on my calculator. So I'm getting, I'll approximate it, maybe 26.7. I'll just round it to one decimal place, but this will be feet per second. I think that's a reasonable answer. I'm sure you could get a different one, especially like maybe this line should have been a little bit steeper and you could get like a couple different points, but I think this is a reasonable answer for this value. All right, let's try the same thing, but for t is equal to 20 seconds. Again, just we'll get an approximation for it. I think the tangent line, it's really hard to draw this one on here, but maybe something like this. This will be my tangent line. So my 2 points, let's see, we have one here. I'll use this point itself, which is 20 comma 300. I don't know, maybe I guess I could use this point here. I'm just gonna have to estimate this, but it looks like it's, maybe 25 comma, maybe 260. It's the best I can really do. So my 2 points were, it goes through 20 comma 300 and also 25 and maybe like 260. It's a decreasing line, so I know the slope is going to be negative. So my slope will be, it'll be 260 minus 300 over 25 minus 20, which I'm going to get this value in a calculator. So I do 260 minus 300, which is negative 40, and I'm dividing that by 5. And so I get negative 8. And I'll add on the units of it has to be feet per second. This seems like a reasonable answer. I might have drawn it just kind of too steep here. Like maybe it was, less steep. I'm sure you could get smaller numbers, but I really think this is good enough. For the final part, we want to figure out what is happening at t is equal to 30 seconds. So like what's happening here? Again, I'm going to try to draw a tangent line to the graph to see what we get. Okay, so this time, we have this spot here, and like maybe this is my tangent line. If I'm using a couple of points, I think using the point 30, 100 is good. And then maybe my other point will be here, which appears to be like, I don't know, maybe 28 comma 200. Again, it doesn't have to be perfect. We're just getting an approximation. So my points are 30 comma 100, and I'm saying, roughly 28 comma 200. If I put this in the formula for the slope, I'll do, okay, so it's going to be, let's see, we get 200 minus 100 over 28 minus 30. I'm going to do this directly in my calculator, so that's going to be 100 divided by negative 2. Probably did not need a calculator for that, but we get negative 50. And that would be negative 50 feet per second. Now you might get something different if you drew a slightly different tangent line, but that's the idea for this problem. The idea is if you want to know velocity and you have some equation that tells you distance, you can draw a line that goes between given points. You can then use points on that line to figure out the slope. The slope has units of feet per second, and that means it is a velocity.